We are ready to do a multiple regression, and we're going to use the Duncan dataset, which is the one that we looked at in the previous video on scatter plots. So again, we have three variables besides the type, which is categorical. We have three continuous variables, one on income, one on education, one on prestige. What we would like to do is see whether or not income and education are both providing unique contributions to the explanation of prestige levels. So before we go to the multiple regression, we'll just do a couple of typical things where we will ask for descriptive statistics and look at the correlations. We already know that all these variables are positively correlated from the previous video when we looked at the scatter plots, but we can see the numerical correlation coefficients. First, we will just quickly add the psych package, because that's where we get our describe function. So we're going to do describe Duncan, and we're going to take out the first variable, which is type, and that'll make things a little bit cleaner. So that gives us we have our sample size of 45. We can see the average income, education, prestige. See the previous video for a bit of information on how these are scaled, and also the standard deviations. These are pretty large standard deviations given the means, so we have a wide distribution of scores on all three of these variables. You have your mins and maxes here. And now that we have those, we can also ask for correlations among these variables. And again, we need to get rid of that first column for this. And we can see, again, all of these are strongly correlated with each other, especially prestige is highly correlated with income and education, whereas income and education are also highly correlated, but a little bit less so. So now we're ready to go to the multiple regression. And the main thing that's different about a multiple regression compared to a simple linear regression in R is that we just need to tack on the second regressor, or third or fourth, depending on how many regressors you have. So in this case, we just have the two. Remember, we need to start by coming up with a name of a model. I'm just going to call this D mod. I find shorter variables are easier because you don't have to retype long strings of characters over and over again. Linear model. Then we have our Y variable, which is prestige. That's the thing that we're trying to explain. And then that's as a function of income. And if we just did this, we would get a simple linear regression, kind of a little bit like what we were doing up here. But we're going to add in education as well. And our data is Duncan, and we're ready to go. Go ahead and run that. We can see that the model is there for us, but we can't see any of this until we go ahead and ask for a summary of it. So you're going to use the capital S summary function, and we're going to put in D mod, and we're going to ask for the adjusted R square. Okay, go ahead and run that. And we have covered how to interpret all of this in class, but we can see, first of all, that the R square is 0.8282. It's a little bit smaller, but pretty similar when we look at the adjusted R square. The F statistic is very high F, 2 degrees of freedom for regression because we have two regressors. 42 makes sense because we have 45 cases, minus 2. Minus 1 is 42. And then our p-value has many, many zeros in front of it. So this is a p-value that's super, super tiny. So this is significant. So education and income combined are significantly explaining prestige. And when we look at the coefficients, we have our intercept, we have our partial regression coefficient for income, and our partial regression coefficient for education. And for both of these, a 1 unit increase in each of these things is associated with about a 0.5-0.6 predicted increase in prestige. They're both positive, which means that a job that has more income and a job that has more education, both of those things are associated with greater prestige, which makes perfect sense. And then both of these are p-values that are quite small, 0.00001, and this one has 5 zeros in front of it. And so both of these are significant, telling us that income tells us something above and beyond education, and education tells us something above and beyond income. They are both uniquely contributing to this regression above and beyond the other regressor. The last thing that we might want to do, and we will talk about this in class, is get a sense for how much of a problem it might be that the two variables are highly correlated with each other. And this is the variance inflation factor, or VIF. And while there are no hard and fast rules about how big this number needs to be a problem, the higher the number, the worse things might be for our standard errors. Basically, these will tend to get larger if our VIF scores are higher. And VIF can go from 1 to infinity. But some people have said if you have a VIF over 10, then you've got an issue. But the book talks about why that might not be the case, and there's some situations where more collinearity than you might like is maybe not such a huge problem. But still, I want to talk about how to get this in R. So it's really easy. You just have to put VIF, and in parentheses, you put the model that we already created from the regression, so dmod, and then that's it. Go ahead and run it, and it's going to give you your VIF scores for income and education. These are both a little over 2. When you have 2 regressors, the 2 numbers will be identical. But if you have 3 or more regressors, then the numbers will be unique and different from each other. 2 is certainly nothing to worry about. And in general, I find like in my own research, collinearity doesn't seem to be a problem that I have to worry about, but it's worth knowing that there is this statistic to check, and that maybe it's something to be concerned about if your scores are at all in the double digits, which they're clearly not in this case.